everyone, this is Himanshu, and in this lecture, we will study about a basic difference between the nuclear fission and fusion. So, in order to study that, let's do one thing. Let's make a table here. Let's write a nuclear fission and nuclear fusion here. Now, the very first point is the definition itself. So, fission is splitting of the large atom into the two or more smaller ones. So, if this is an atom, it will be break into the smaller atoms. So, this is what the fission is. Now, in the fusion, it is basically the fusing two or more lighter atoms together into a larger one. So, you must have known this thing because we have studied this a lot while we are in the 8th class, 9th and 10th. So this is the basic difference between the definition. The next thing is about the natural occurrence of the process. So the fission reaction, it actually does not occur in the nature so often. So it does not occur in nature, normally. But in the fusion reaction, it does occur in the nature, and we can see in stars. So it does occur in nature, and the example is basically the stars. One of the example of the stars can be like the sun itself. So this is where the huge amount of the fuel has been depleted and burned, and that is the reason why it has so much amount of energy, and this is the reason why they are so bright. So the nuclear fusion reactions occur in star. So yes, it occurs in nature. The third point is basically about the byproducts of the reaction. So in the fission reaction, it produces many highly radioactive particles. So many highly radioactive particles are released in byproduct. But in the nuclear fusion reaction, only the few radioactive particles are released during the fusion reaction. The fourth point that we're going to discuss is about the condition. So to make the fission occur, a high speed neutrons are required. So high speed neutrons are required, whereas in the nuclear fusion, the high density and high temperature environment is required. So that is required in the fusion. The next point is about the energy requirement. So the nuclear fission actually requires a little energy to split two atoms into a fission reaction. But here in the nuclear fusion, it requires a very high energy to bring the two or more protons close enough that the nuclear forces overcome their electrostatic repulsion. For that, very high energy is required. Now, the sixth one is about the energy released. So generally, in the nuclear fission, the energy released is 1,000,000 times greater than what it generally in the chemical reaction. So it is what we can say that it is 1,000,000 times of what is released in chemical reactions. Whereas it is, and this nuclear fission, the energy, it is actually lower than the fusion. But in the fusion, it is actually the 4 to 5 times of nuclear fission, means 4 to 5 times of the nuclear fission energy is released in the nuclear fusion process. Means it is 4 to 5 times more effective than the nuclear fission. And when we talk about the nuclear weapons, The nuclear fission actually occurs in the atomic bombs and the atom bomb. So the atomic bomb, or you can say an atom bomb, the nuclear fission occurs. But here in the nuclear fusion, it is hydrogen bomb. It has not been tested anywhere yet. So this is the most dangerous one actually. And finally, the energy production, the fission is actually used in the power plants, and the nuclear fission is basically still, they are developing a better technology so that they can use it. So we can say it is for the experimental. It is not that much in circulation. So this is mainly about it. And we can also talk about the fuel also, that the uranium is a primary fuel which has been used in the power plant here, uranium, whereas here hydrogen isotopes are used, like deuterium and the tritium are actually the primary fuels which have been used in the fusion power plant. And that is mainly a difference between the nuclear fission and the nuclear fusion reactions. So in the next lecture we will study about the nuclear power reactor. Thank you guys.